for that failure there. Okay, I believe we're now recording. All right. So once Taylor published this piece, people went out and they started looking at the data and found that it did appear as if the Fed was following the Taylor rule. And then subsequently, a bunch of economists looked at data from other westernized countries and found that their central banks as well seem to be following the Taylor rule. What you see on the screen is a version of the Taylor rule. This particular equation is the monetary policy rule for our dynamic aggregate demand model. Okay, let's look at what's in here. What this says is the Fed will set the interest rate I sub t equal to the current rate of inflation plus the natural rate of interest plus some part of the difference between the actual rate of inflation and the target rate. Pi sub star is the target rate of inflation, plus some fraction of the difference between the actual GDP and potential GDP. So what we're going to do is we're going to take each of these parts and kind of decompose it and figure out what this whole thing is saying. The two pi terms here are parameters, and they are fractions between 0 and 1. Okay, so what does this monetary policy rule say? Let's suppose the economy is at full employment, so the output gap, Q minus QP, is 0. So that last term drops out. Let's also assume that the actual rate of inflation is equal to the Fed's target. So that middle term drops out. Okay, what that means is the actual interest rate, the nominal interest rate, will equal the rate of inflation plus the natural interest rate, which, because we're at full employment and potential GDP, is equal to the real rate. So what you end up with is I equals pi plus R, the real interest rate. Does anybody have questions about that?
Can you repeat that?
Sure. If the output gap is 0, the last term drops off. If the inflation rate is equal to the target, the middle term drops off. So all we're left with is I equals pi plus rho. Remembering that when the output gap is 0, rho is equal to the current real interest rate. What that tells us is the interest rate equals the inflation rate plus the real interest rate. So it's a very straightforward story. What determines the real interest rate? This is not a trick question. The real interest rate, particularly when the output gap is 0, is determined as the interest rate that equates the demand and supply of loanable funds. Okay, so the real interest rate—
Did you say that again? Sorry.
Yes. The real interest rate is always the interest rate that equates, that comes out of equilibrium in financial markets, loanable funds markets. So it's the interest rate that equates saving and investment. Okay, now that's always true. When we're at full employment, that real interest rate is equal to rho. So what that tells us is that the nominal rate is the inflation premium plus the real interest rate as determined to equilibrate financial markets. Okay, now just a little fun since it's Friday. Okay, let's suppose that the supply of loanable funds is really large relative to the demand for loanable funds, investment demand. What does that say about the real interest rate? Supply of loanable funds is really large. Demand for loanable funds is small. What does that say about the real interest rate?
It's big.
It sounds like supply is greater than demand, right? So that should drive the real interest rate which way?
Should drive it down.
Yes. And if the supply is really large relative to the demand, the real interest rate could be really small, close to zero even. Does everybody understand that? Anybody understand that? Rachel, does that make sense to you? Okay. Lillian, does that make sense to you? Okay, now, here's a question. What if the equilibrium real interest rate is negative? Is that a good thing or a bad thing?
And
No, it doesn't depend.
does that mean the inflation rate is just higher than the interest rate?
It does, but that's not the issue here. Do we want to be at full employment and potential real GDP? Chester?
Yes.
Yes, we do. To get there, the real interest rate has to be negative. Say, I mean, that's the scenario that we're setting up here. Okay. How do we get there? Is that easy or hard to do? Chester?
Hard.
Why? I'm just asking. It is hard. Why?
It takes time, I guess.
No, that's not the issue. How do you reduce the interest rate? How would the Fed reduce the interest rate? This is not a trick question.
They would increase the money supply.
It would increase the money supply, okay? And so the real interest rate falls until it hits zero. And then what happens? The Fed increases the money supply some more and tries to force it negative. Does that make sense, Chester?
Yeah, it does.
Okay, now let's think about what a negative real interest rate means. It means lenders are paying borrowers to borrow the money. Do you know any lenders that would want to do that?
No.
How would they make money that way? Okay, so we are literally off the graph, as it were. And so if the natural real interest rate is actually negative, then we're in a heap of trouble because we don't know how to get the interest rate that low. Without being able to get that interest rate that low, what is the state of the economy going to be? Is it going to be GDP higher than potential or GDP lower than potential?
Be lower.
Lower.
Yes, it means there would be a natural tendency to stay in a recession for a long time. And that, by the way, is what a lot of economists think we're in. This is called secular stagnation.
What's the difference between that and a liquidity trap?
The problem with the liquidity trap is people are willing to hold an infinite amount of money. The problem with the scenario that I just told you is people aren't willing to, or I should say businesses aren't willing to borrow to invest. So they are related. I mean, they are similar kinds of things, except typically liquidity traps don't last as long. But that's a really good question, Matthew. Okay, now other questions. Okay, the secular stagnation story that I just told you isn't a central part of the DAS model. It's just something that I thought of in the context of this monetary policy equation. It jumped out at me, and so I thought I would share it with you. Okay, the Fed has a target interest rate. Okay, you can look it up right now and see what the Fed's target interest rate is. What does the Fed do according to this monetary policy rule if inflation rises above the target rate? Is that a good thing or a bad thing from the Fed's perspective? Bo?
I'm sorry, I was looking up the Fed's target interest rate. Could you repeat it?
Yeah, what I was saying is, suppose the actual inflation rate is above the Fed's target. Is that a good thing or a bad thing from the Fed's perspective?
That would be a bad thing.
Correct. So what do they do according to this equation? I'll give you a hint. Theta pi is positive.
Okay.
So if pi rises above pi star,
then what is that? The interest rate
yes,
would be, the interest rate would decrease?
I don't think so. I think it's the other way. If
Okay.
inflation is too high, the Fed would raise interest rates to try to slow the economy down and bring the inflation rate back to target.
Okay.
Does that make sense?
Yes.
And that's why this theta is a positive term. So what's in the brackets here, if that increases, then interest rates go up too. Okay. Everybody have that? Everybody understand? So what we're saying here is the Fed responds automatically when the actual inflation rate diverges from its target. For example, this morning, the BLS reported the latest inflation figures. The latest inflation figures. Where is that in my email? Okay. The CPI for March Consumer Price Index fell 0.4%. That's quite unusual for the CPI to actually go down. What would you expect the Fed to do when the CPI falls?
Decrease interest rates?
Say it again, Sid?
Decrease interest rates?
Yeah, that's what you would expect to see. Okay. This is an odd situation in that we're not just under the target, we're actually negative. That's scary. Okay. Of course, it's just 1 month. We'll see what happens. The reason for the decrease in the CPI was primarily energy prices, as well as hotel and airline airfares. So that may not last. I know that OPEC is meeting today to try to shore up energy prices. So we'll see. Okay, moving right along. Okay, the last thing. Suppose GDP falls below potential. What is the Fed going to do to interest rates?
Decrease them?
Yes. When GDP falls below potential, the Fed wants to speed up the economy. And so they do that by lowering the nominal interest rate. Okay, so what the Taylor rule said was central banks pay attention to two key variables. One is GDP and one is inflation. So when the GDP gap changes, they automatically change interest rates. When the inflation rate changes, they automatically change interest rates.
I have a question.
Yeah.
So for the GDP portion, why is it theta psi instead of like theta q?
I don't know.
Oh, is that just what it is?
It's
It's
just what it is.
Okay.
You know, so now you got me wondering. I don't know. It's just a Greek letter, so it doesn't matter that much. Okay. Okay, so the final point I wanted to make about the monetary policy rule is when inflation diverges from target or when GDP diverges from potential, these divergences don't require big decisions on the part of the Fed. They're almost automated. They almost happen without any decision to be made. Okay, remember when we talk about fiscal policy, at least when we did it back in ECON 201, we talked about the difference between discretionary fiscal policy and automatic stabilizers. Can somebody remind us what the difference is?
Because eggs are hard to find.
Jack, any ideas? Can't hear you. What's that?
What happens on its own?
Yeah, automated.
What's the difference between discretionary fiscal policy and automatic fiscal policy?
I suppose discretionary is where they have to make a decision, they have to change something, whereas the automated one is where it happens naturally, like the economy would, say, consumer spending, people would buy less, and that would counteract, say, a rise in inflation.
Something like that, yeah. Discretionary, since we're talking about fiscal policy, discretionary requires an act of Congress, to change tax rates or to spend more or spend less. Automatic fiscal policy, automatic stabilizers would be something like the income tax system. When the economy goes into recession and people's incomes go down, they automatically pay less tax. The social safety net, the welfare system. When the economy goes into recession, more people automatically qualify for welfare, right? So the budget deficit always grows automatically during economic slowdowns, and it always decreases during economic expansions. That's automatic, okay? So the same thing or something very similar to it is happening here with a monetary policy rule, all right? So essentially what's going on is the Fed is saying, we're paying attention to inflation and to GDP. When those things change, we automatically know what we're gonna do. If something else dramatic happens, then we'll have to meet and make a separate decision about what's going on. All right. Any questions?
Just to be clear, you said automatic fiscal policy. It's just automatic that we pay less in recession and not the tax rate changes, because that's what discretionary fiscal policies would be.
Basically, let me say it again. The Congress sets up a system like the tax system. Then they let the tax system go. As GDP grows, people pay more taxes. As GDP declines, people pay less taxes. Those tax revenue fluctuations don't require Congress to act because they've already put the system into place. Okay, so by contrast, something like the Trump administration's tax cuts in 2017, that was a discretionary policy change because they took the rates and they lowered them.
Okay, thank you.
Sure. Other questions? All right. Now we're ready to put things together. I know this is exciting to you. I can see the excitement on your faces, especially Jess's. Yeah, okay. So remember, we have a bunch of equations here, right? We have this aggregate demand equation, we have the Fisher equation, we have the monetary policy rule, and we have adaptive expectations. Okay, so let's talk through these things. One of the things that differentiates between modern macro models and older macro models is modern models explicitly incorporate expectations into them. If you think about it, things like investment, expenditures, like saving, like borrowing, all of those things require thinking about the future. And we don't know for sure what the future holds. So people, economic agents, have to make predictions about the future. Okay, that's what we're doing here with this fourth equation in the in the model. Okay, there are several different ways that we can model people's expectations. For this class, we're going to do it in the simplest possible way. And that is using something called adaptive expectations. Adaptive expectations is a pretty good model of expectations. There's a lot of evidence that that's how most people actually operate. What it means is they extrapolate from the past to predict the future. Okay, so in this case, let's look at the inflationary expectations equation here, the fourth one. What this says is people expect the inflation rate, that's pi e, in period t plus 1, that's one period into the future, to be equal to what the inflation rate is in period t, which is today. So what we're saying here is you look back one period and you use that one period back to predict the future. Okay.
Is it looking one period back, or is it looking at the inflation right now?
Yes, it is, Sid. It's both. Okay.
Oh, okay.
So if you're trying to predict at the beginning of 2020 what the inflation rate is going to be over 2020, then you would look back at 2019, right? So you're always looking ahead one period. No, say it differently. You're looking back one period to predict one period ahead. Okay. Say, for example, Sid, you wanted to predict the inflation rate in t plus 3. Then what would you think the inflation rate in t plus 3 will be?
Would it be the inflation of t plus 2?
Correct, except the problem is that's also in the future. So
Right.
how would you predict the inflation rate in period t plus 2?
T plus 1?
Correct, except that's also in the future. So how would you predict? Yeah, see, so
The
it's
future's just gonna be now.
it's just going on. Okay. Now, a more realistic model of inflationary expectations would probably use several periods. You would look at the weighted average. So if we were looking at what do we expect the inflation rate to be in 2020, you would probably use a weighted average of the last several years' inflation rates. Okay, so you could say something like half of last year's inflation rate, a third of the year before's inflation rate, a sixth of the year before's inflation rate. So you're weighting recent years more heavily, but you are looking at a trend over time. Okay, we could do that here, but it just makes the math more complicated because you're dragging around these extra terms. So we can get the full flavor of how expectations can affect things with this simple version of the model right here. Other questions? Peter, you good? All right. Okay, now, so let's just remind ourselves what we've got here. We recognize rho as the natural rate of interest. Here's our inflation, our expected inflation rate. ET is a demand shock other than a monetary shock, since monetary shocks would show up here. Okay, here's our monetary rule. So what we do is we start from the aggregate demand equation and we substitute out the real interest rate here by using the Fisher equation. So we plug the Fisher equation right into there. So instead of R, we have I minus pi E. Does everybody see what we've done? Rob, does that make sense to you? Maybe? Okay, we're literally just plugging this in for R. Okay. Then what we do is we substitute the monetary policy rule in for the nominal interest rate. Then finally, we substitute in our inflationary expectations term. So we replace this term, which is unobservable because it's expectations, with this term, which is observable. So we end up with a big long equation that starts off Q equals something, and there's a whole bunch of stuff on the right-hand side that we, with algebra, simplify it as much as we can. And when we get done, this is what we end up with. Okay. So there's good news and bad news. The bad news is getting to this point takes a lot of algebra. The good news is once we're here, it's actually pretty straightforward what it's saying. Things to notice here. First, the coefficient on inflation is negative. What does that say about the dynamic aggregate demand curve on the graph?
As
Say it again?
inflation goes down,
Well, yeah, but what does that say about the graph?
it's downward sloping.
Correct. Our DAD curve is downward sloping, which is what we want it to be. Okay. Another interesting thing. What's the coefficient on Q sub P here?
1.
It is 1. What that means is every time potential GDP increases, aggregate demand increases proportionately. That's going to be important when we start using the model. Okay, this, by the way, it comes from Say's law. Do you guys remember Say's law from your economic history, whether you took the course or not? Anybody take American economic, or sorry, history of economic thought, rather?
I'm in it right now.
Okay, have you talked about Say's law yet?
A little bit. It's that supply dictates demand.
Correct. Supply creates its own demand. So here's the argument. Okay, the argument for Say's law is, suppose a firm produces $100 worth of goods and services. When it produces $100 in goods and services and sells them, it also creates $100 worth of income. That income provides the spending power to buy the goods and services. So it's kind of a circularity thing here, right? Producing $100 worth of stuff generates $100 worth of income, which can then buy the stuff. Okay. Finally, what do we know about things inside the brackets? If we change the target inflation rate, or if there's a positive demand shock, what happens to aggregate demand?
It shifts.
It shifts. Okay. So this minus beta 3 term is the slope of the DAD curve. This sum of 3 elements in the square brackets is the vertical intercept. Okay, so when we start playing with the model, what we're going to be doing is doing things like looking at demand shocks, which shift the aggregate demand curve, or looking at supply shocks that shift the aggregate supply curve. Okay, so if you just remember this part of the algebra, that's the most important thing here.
So I have a question about the omega p. What is that exactly?
Right here?
When looking at the beta terms, how it has like alpha, omega, then p. What is the
theta,
p in
theta?
Theta? My bad.
Yeah. See, that's what you get when you don't have Greek life. Yeah. Okay, those are simply parameters, and so theta p. No, that's not right. I think that is actually, that is a different parameter. When I was translating the Greek letters, like this one is not right. All of those parameters have a value between 0 and 1. So we're just multiplying fractions together, basically.
Oh, okay, thank you.
Okay. Okay, other questions? I'm going to go back and check that and see what it's actually supposed to be, because I don't think that's right.
In the book, they had theta pi and theta y.
Maybe that's what this, yeah, I bet you the theta p was supposed to be a theta pi. So, yeah, so I
Are
will
they
fix
all
that.
supposed to be theta pi then?
No, they're not. There's an error in there somewhere. I will fix it before I send you this. Okay, so apropos to that point, we have, I think, one more slide left, and then we'll be done with deriving the aggregate demand curve. And so I'm going to start a new set of PowerPoints on using DAS starting Monday. All right, that will remind me. Okay, now there's one little thing left to do. The one equation that we haven't talked about in a week is what Mankiw calls the Phillips curve equation. It's really the dynamic aggregate supply curve. This is written down twice here. You can use either one that you want. What we have here, this is literally the dynamic aggregate supply curve. And what it says is the inflation rate is the expected rate of inflation plus a fraction of the output gap plus a supply shock if there is one. Okay, so the very last step is to take our inflationary expectations equation and plug it into the pi e terms so that we end up with a DAS curve that is comparable to the DAD curve, meaning that we have a positive slope, which means an upward sloping DAS curve, which is the way it's supposed to be. And then these are the three things that would shift the DAS curve. Okay, does everybody see what we've done? Anybody have questions about that?
Is V the supply shocks?
V is the supply shock, yeah.
Okay, just making sure. Thank you.
Okay. This is kind of interesting here. What's going on here with minus phi QP? What does that mean? Aspen, you with us?
Can you repeat that question?
Yeah. Okay, my question was, what's going on with this thing right here? What does that thing say? When potential real GDP goes up, what happens to inflation?
It goes down.
It goes down. Does that make sense to you? Think about it. When potential real GDP goes up, it's like the principal's aggregate supply curve is shifting to the right. And when it shifts to the right, it's moving along the aggregate demand curve, which means higher quantity, higher real GDP, but lower price level. So that's exactly what's happening here, right? So economic growth, when this goes up, actually has a disinflationary effect, pulling the inflation rate down. Okay.
So why is the potential negative when the actual GDP is positive? Is it based on which one is full employment?
No, because, well, that has to do with how, with the definition of what a DAS curve is. This has to be positive so that we have an upward sloping curve. Okay, what this is essentially saying is when GDP rises, everything else held constant, inflation goes up as well. Okay, remember where it came from. It was QT minus Q sub P. So what we're saying is GDP is rising above potential, which is causing inflationary pressure. Okay, these are all really good questions. It's easy to get hung up on the algebra and the equations. And it's equally easy and equally incomplete to learn how to shift the curves without really understanding what's going on. So we're constantly going to ask ourselves, does this make sense, what we're doing? All right, any final questions? All right, well then I will